Okay, let's focus now.
Yeah.
Now, last week,
Come on.
we started with discrete random variables. We started looking at the probability mass function. And of course, like all maths, we will talk about a bit of transformation. Yay! Alright, we're thinking about the change if we have got a multiplication of x or adding a constant. Alright, so I'm going to start off with looking at these 5 numbers. You should be able to use your class pad to determine the mean, variance, or standard deviation.
Yes.
Any one of you not knowing how to do it?
Yeah, well,
You don't know how to do it? Oh, alright, let's do it together.
Guys are actually noobs.
If you're not sure, grab your class pad out. If you haven't got a class pad, come and get one from me. You really do need your class pad. Alright? Get your class pad out. Now, we're going to start looking at statistics. Alright, with your class pad, make sure that you clear everything. Alright? You must make sure that you clear everything.
I just got it easy.
Clear it all.
Standard deviation.
So you're going to start off with 10,
How do you know what standard deviation?
20, 25, 30,
The square root
and
of
40. Alright? So once you've entered all the number in, you go to calc. Under calculation, go to one variable. You want it to be one variable, and then the frequency is 1, the x list is least 1. Click OK. Now, x bar here is your mean. Sigma x is your standard deviation. Alright?
Yeah, 100 for variance.
So, x bar from your class pad, that becomes 25. Sigma x, which is your standard deviation, is 10. So, variance is sigma x squared. So, therefore, it's 100. Alright? So, you must know how to work that out. Alright, now, back to the lesson.
Yes.
Slide. So, you do know from your calculator what the mean, the variance, and the standard deviation is. Next thing, this time, a bit of transformation. So, if we increase each score by 5, can you actually work out the mean, variance, and standard deviation? So, we've increased everything by 5. So, 10 plus 5 is 15. 20 plus 5 is 25. 25 plus 5 is 30, and so on and so forth. Alright? Now, I still want you to use your class pad. See what happened to the mean.
Oh. It increases by 5, doesn't it?
Yeah, no.
So, what changes?
The mean.
The mean. Alright. Now, here, I want you to think about why is the variance and the standard deviation not changing.
Because the difference
Alright.
between them is...
We're just looking at the mean.
Yeah.
Next bit,
Yeah.
let's go to the next
Except
one.
if you have that.
This time everything is decreased by 5. No class pad. Can you
20.
work out the mean, the variance, and the
not
standard
20,
deviation?
Yeah, it is.
Yes, it is.
Without class pad.
It is, bro.
No, did we go... Yeah, it is 20, bro.
Without class pad.
Such
Work out the mean, variance, and standard deviation.
And it's just
20, 10...
110.
Yeah.
Nice one.
Now,
It's not 20, bro.
Yeah, it is.
Shut your mouth.
It is 20.
Yes,
It is
I know. That's what I'm saying.
what happened? You know that the variance and the standard deviation
On their own.
shouldn't change, should it?
Oh,
But
but
the
we're going to have some
mean.
dilation.
What happened to the mean? We started off with mean was 25.
Yep.
It went up to 30,
And
and then this time it
Down to
decreased
20.
by 5, it went down to
20.
20. So, can you make a conclusion? What is the sum? What would your summary be?
Mean stays.
So for any set of scores, in terms of statistics, if we change its score by a constant, so we are now doing the transformation. We are shifting. Alright? We are shifting the origin. What happens to the mean? What's happened to the variance and standard deviation?
They stay the same.
Mean is increased by b, but the standard deviation does not change because the spread is the same. So let's think about if the spread is something like this. Alright? If this is the spread, if you move it around, you are adding every number by the same amount. So you are just moving back and forth. Alright? So the mean definitely changes. If this is the mean, if I move it by 5, it changes by 5.
Yeah.
If I move it to the left by 5, it changes by 5. Correct? So this bit here, we actually change the mean. However, the spread is still the same. There's no change at all. So you're just moving the
But the mean was
data set or
shit.
the distribution back and forth. That's all.
I'm fine.
Alright? Now, we're going to look at the next bit. Same thing. This time, I'm going to double each score.
Mean will stay the same.
No,
No. Mean will double as well.
do it.
Use your class pad.
Mean will double as
Use
well.
your class pad.
Mean doubles as well.
And have a look at what happened to the variance and what happened to the standard deviation. Alright?
Double as well. Double as well, yeah?
Yeah, man.
So you're going to look at the variance and the standard deviation.
Yeah, the doubles.
One variable is 3. Okay. Okay, rotate double. What 200 square was 20 square?
400.
What? 20 square.
400, I said that twice. Yes.
You sure?
Is it 400?
20 square? It is. Why are so many people doubting me?
Yeah, it is 100 because it's 20 square.
Why are so many
Now.
people doubting me?
I don't
How did you go from 100 to 400?
2 square. Times it by 2 square.
Times it by 2 square, times it by 4.
Yeah.
So, without using your class pad, I want you to think about what would happen to the mean, the variance of the standard deviation, if we multiply each score by minus half.
Can't have a negative standard deviation, can't you?
Alright?
Can't do it.
What would the standard deviation be?
You can't.
What would the variance be? What would the mean be?
Yeah, it's just a positive version of it. Yeah, you idiot.
You're an idiot.
I'm just not.
What's the mean? 12.5?
What do you think?
No class
No.
pad. Think about it.
This? 12.5. You're adding
So
a bunch
the
of negative
mean
numbers
will then
divided
be-
by something, you're going to get a negative number.
It's negative
Minus
12.5,
12.5. Everything is
25
negative.
and 5.
So therefore,
No.
when you divide by 5, you will have a negative number. The variance.
What do you mean?
Variance will therefore be
25?
25.
What?
Because it's a square.
Yeah.
It cannot be a negative number,
All
right?
When you get 5.
And the standard deviation
It's the root of that.
is actually 5.
Yeah.
Because you get that.
'Cause it's
We
the
are
root
actually
of the
looking
variance.
at just the absolute value.
Absolutely.
Alright? So
It's just
here,
negative.
can you do a summary? If a set of score, if you multiply each score by a constant A, then what happened to the mean? What happened to the variance? What happened to the standard deviation? So if you have got something like this, say this is a small distribution, you've enlarged it into the large distribution. What happened there? What happened to the mean, what happened to the spread, and what happened to the standard deviation? Alright? So think about this. You've got something small, and now you're multiplying with a factor, A.
Wow.
The mean should be increased by factor A. Right? So from here to here, from something like this to something like this,
Whoa.
is increased, whatever the
Calvin.
factor is, they increase by A. The spread will be slanting different. The variance, you've got to increase it by A squared. And then the standard deviation, you increase by a factor of absolute value of A.
Variance times A squared.
Alright? So that sign here, you've learned it, that's absolute value of A.
True.
Now we're going to apply these statistics to the probability distribution. So for any discrete random variable x, the linear change of origin. So a discrete random value variable x undergoes a linear change of origin when outcome of x is changed by addition or subtraction of constant value b.
English.
So this time, like I say, what you're doing is just basically moving this that to your left or to your right. That's all. So what happened is, if I've got a change of origin defining by that, so we do have that is plus or minus. My fault. All of you, can you please change that? This is plus or minus, not just plus. It's plus or minus b. Alright, please change that.
Shut up, mate.
Take it back, mate.
So when you think about this, you're moving left and right. Alright? You are actually moving the same thing, the distribution is just moving left and right. There is no change in spread at all. So therefore, the variance of x and is the same as the variance of y. The standard deviation of y is the same as the standard deviation of x. So, quick summary. Adding the value of b to x increases the mean by b. It does not change the variance of the standard deviation because the spread of the score remains the same. No change at all. Alright? Remember your transformation? You're just moving left and right. That's it. Now, that's the linear change of origin. This time is the linear change of scale. You are going from something small to something big. This to this, or this to that. Doesn't really matter. Big to small or small to big. You've got a scale factor of A. So y is actually A times x. So we therefore observe that the expected value of y is A times the expected value of x. The variance of y is A squared times the variance of x. And the standard deviation of y is absolute value of A times the standard deviation of x. Alright? So,
That's some important stuff.
expected value and standard deviation, both of them increase by a factor of A, except standard deviation is the absolute value of A. Variance is increased by A squared. Increased by A squared, if A is minus, if you square it, it's still positive, right?
Ooh, yes,
Happy with
I
that?
used to
You've all got that? So we're going to move on to some examples. Or actually generalization. So for generalized linear transformation from y equals to ax plus or minus b, ey equals to a times ex plus or minus b. Can you change that, please? Plus or minus b. And then variance y is a squared times variance of x. because plus or minus b doesn't make any difference. The spread is still the same. Plus or minus b, again, does not make any difference to the standard deviation. The spread is the same, but the change in scale. You've got to think about the change in the standard deviation as well. Alright? Now, let's go on to the next bit. Can you try this, please? So, if I've got a random variable x with an expected value of 12.5 and variance of 2.5, can you find the expected value of EY, where y is 3x plus 4? So remember, you need to change your expected value by the scale. Also, when you move it to left or right, plus or minus. All right, think about that. So expected value should be that. It's just basically 3 times EX plus 4. It will become 41.5. But the variance you need to square the
That's 27.
square A. So you've got 3 squared, which is 22.5. Can you do the other two, please? D is the standard deviation.
Root 10. Awesome.
Right, check your answer, please.
The variance is 2.5.
So I need to take the square root of the variance because of standard deviation. So it's 2 times square root of 2.5.
That's root 10.
Alright? Can I move on to the next example? Happy with it?
Wait.
Yes. Alright.
Yes, I am. Oh, you're so far ahead. What? Why do you go ahead like that?
Alright.
This is so good.
Bro, why you stay at the
So
bottom?
expected value
Well, I don't know the next
multiplied by the
question.
factor, the scale factor, and whatever translation.
Because variance is the square of standard deviation. So you need to find the standard
Alright,
deviation.
example 2. Now the discrete random variable x has a mean of 12 and variance of 16. A second discrete random variable y is defined as y equals to ax plus b, where a is greater than 0. Alright? The mean of y is 8 and the standard deviation of y is 3. Determine the value of a and b. Alright, I don't know why I've got 4 dots there. Alright, you should be able to do that. You know that EY equals to A times EX plus B. Alright, so you should be able to substitute your value in. What I do is, I actually write down the information because I need to work out the standard deviation. You are asked to find the standard deviation. So I know that the standard deviation is square root of 16, which is 4. Alright? don't mind if you use sigma square x or and sigma x, that's fine. Or maybe in this case, you just write down via Rx or SDX. And you know EY equals A times EX plus B. You got to solve simultaneous equation now. You've got two unknowns and you would have two equations. Which means A equals to 8 equals to A times 12 plus B. Now, the next bit is you know that the standard deviation of y is A times SD. Alright? In fact,
Plus or minus.
you got two unknowns, two equations. You don't have to even worry about solving simultaneous equation because that should give you your A. Correct? Yeah? That should give you your A. And therefore, 3 equals to 4A and A equals to 3 over 4.
Plus or minus, no?
No, it's I'm just giving you the absolute value at the moment.
Oh, right.
Alright, think about it as absolute value. And therefore, substitute B equals to minus 1. So you must know how to solve, interpret the
B could
questions.
also be negative 17 as well.
Sorry?
B could also be negative 17. I mean, no, 17. Because it's absolute value of A, it's not A.
It's absolute value of
So it could be plus
A.
or minus A.
It's
So you have two cases.
you can't have minus 17 in this case.
No, it'd be plus.
So is A is greater than 0 as well?
Sorry?
Where A is greater than 0.
Oh yeah,
Yeah,
right.
great.
Yeah,
A
that,
has to
yeah,
be greater
that's
than
correct.
0, so it cannot be.
Yeah.
It cannot be.
Yeah,
minus.
yeah. But it could, if
Right.
that wasn't there, it could be.
Because it's given A is greater than 0.
Yeah.
Alright, next one. Example 3. The probability, the discrete random variable x has a probability mass function defined by this. Given that the expected value equals to 1.6, determine the values of the constant m and n, and hence complete the table below. Alright? Now, how would you do this?
Simultaneous equation.
Simultaneous equation, you also know that the sum of this equals to 1. Alright? So you could work out what that is. That will be the probability if x equals to 0, that's 4m, 3m, 2m, m, and that's n, correct?
Yeah.
Then the expected value is x times the probability. That times that, that times that, that times that, that times that. Alright?
The x is the x times the probability of x. So 1 times 2m, whatever, 3m. So the probability of x is 5, 0.1. And then x is, so say the probability of, probability of 5 is 0.1. You're going to multiply that by 5. Just say it is. And then you're going to add up everything. So like probability of 1 times 1 plus probability of 2 times 2. Yeah, you add them all up and that gives you expected value.
Alright, so 4m plus 3m plus 2m plus n equals to 1. Then m plus n equals to 1, which is your equation 1. And you know that expected value is x times probability of x. So 0 times 4m is 0. 1 times 3m is 3m. 2 times 2m is 4m. 3 times m is 3m. 4 times n is 4n.
Where'd you get the n from?
Sorry?
Where'd you get that y to an n?
N is there.
Yeah, but how does that fit into?
Because when it's n is
When
equal
n, x equals to 4, n is there.
Oh, there's 5 boxes. Yeah.
Alright? So, therefore, you should work out the second simultaneous equation. 10 plus 4n equals 1.6. Solving it, n equals to 0.08 and n equals to 0.2. And this should be a calculator assumed, I would say, so that you can go back and work out all the probabilities.
Yeah, it doesn't. It's not.
So that is
The second equation.
4m,
Just
4
when you
times
solve
0.8
for
is
expected value.
0.32. 3 times 0.08, 0.24. 2 times 0.08 is 0.16. That's 0.08. And that you work out 0.2.
Wait, isn't it 11m
Alright.
plus 4n equals?
No, 3 plus 3
Wait.
plus 4.
3 plus 4 plus 3 plus
6
4.
plus 4.
6
10.
plus 4. So 1 times 3m, 2 times 2m, 3 times m.
Yeah.
Alright.
Yeah. So from there, you should be able to work out probability between 1 and 4.
Equals to 1.6.
Because it's just stated that it's equal to 1.6.
Greater than 1, greater than equals to 1, or less than or equals to 4. You either sum all these 4 out, or one take away 0.32, which could potentially make life a little bit easier if you could notice that. One take away 0.32, which is 0.68. Now, since this is calculator assume section, how are you actually going to use your calculator to work out the variance and standard deviation?
You should put it in your calculator.
Put in your calculator, how?
Statistics, yeah.
Thank you. Statistics. I'll go through it again. And 0.2. Alright, go to statistics. Let's do it again. Let's work on this together again using your statistics class back. Alright? Now, again, this time clear all. Edit, clear everything. List 1 is your 0, 1, 2,
Nice.
3, 4, your x. Alright? List 2 is your probability. And then 0.2. Alright? So once you've done that, you go to calc again. Go to one variable. This time, you have to change the frequency. The frequency is now list 2, which is your probability. Alright? And then, tap OK. You now have sigma x equals 1.499, which is your standard deviation.
Why doesn't it give us this?
Alright?
Variance.
1.496663. So what you need to do is use your calculator, square that number. So if you square that number, it's 2.2399. I gave it as 4 decimal places, but in terms of standard deviation and variance, I think 2 decimal places should be alright.
For the investigation, do you want 4 3?
I don't know, I can't remember.
Investigation.
Investigation? Why?
Like the one, just how many do you really?
Well, you're not doing probability statistics.
No, but for
I think
length.
depends
Length of line.
probably two, length 2. 2 decimal
Okay.
places.
And we put units fine.
Oh, you've got it, yeah. Alright, so the expected value of y,
Do you have a supreme
if you
sticker?
know that y equals to 3x minus 3,
'cause you don't
so
do
it's 3
variables.
times e expected
One
value of y is
variable,
3x minus 3, which is 1.8, and the variance is
Do you have a
3 squared
supreme sticker on your desk?
times, which is 20.1591 or 20.
I'm so hot,
Which
but
is him.
Alright,
I'm
two
so
decimal
hot.
places.
I don't know why anyone would waste a supreme sticker. Math.
Okay, let's go to example 4. This is a long one. The results of the calculator assumed section of a year 12 methods test has a cohort mean of 37% and a cohort standard deviation of 17%.
This
It was
happened
deemed
before.
by the course teachers that it would be appropriate to scale all the results. So let X be the raw percentage results of the calculated assumed section and Y be the scaled score. So you are transforming the score from X to Y. Alright? Two situations. One is just simply adding everyone by 10%. The other one is divide the raw score by 0.5 and then plus 50%. That's one. So you need to calculate the scale, mean, and standard deviation if the following transformation will apply, or scaling. And then determine the value of A and B in Y equals AX plus B to 2 decimal places if the course teachers aim to scale the calculator assumed mean to 58% and the standard deviation to 15%. So here, part B, you're thinking of EY now is 58% and the standard deviation of Y will be 15%. Alright, you've got the information there, you should be able to work those out. Now, and then you need to comment about part C. We'll talk about part C in a few minutes, but I would like you to use the information I've taught you to actually work out the scale and mean standard deviation of the following transformation. If the transform, of Y equals to AX plus 10 and Y equals to minus 5X plus 50. Alright?
Oh, why is the number like ugly?
Now, I've shown you the first one. So EX plus 10 is 37% plus 10 is 47%.
So
And there's no change in standard deviation. So we are just basically transforming it, adding everything by 10%, that's all. Not changing the spread. The next one, we will change the spread. We're dividing it first and then add 50%.
Three, five.
There goes one
classic. That's funny.
All right.
Question two.
I got 68.5% and 8.5%. All right.
Not appropriate.
So the next bit, you know that the standard deviation of Y equals to the the absolute value of A times standard deviation of X. You know the standard deviation of X is 17%, standard deviation Y is 15%. So A times that gives you 15%, therefore you should be able to work out what A is, which is 0.88. Now it asks you to give it to 2 decimal places, but I would recommend that when you're using your class pad, alright, you've got a lot of numbers, a lot of decimal places. When you go to the next bit, just drag it down, rather than use the calculation, which is 0.88. Yes, you're writing it down as 0.88, but in the actual calculation later, you should actually work it out. So instead of, yes, you can write it down 0.88, I got 25.35 because I used all the number from the class test.
Yeah.
Use that, please. Alright? You can work that out. Then you can work out what B is. Alright? And then, now, part C. 2 parts. First, you've got to calculate the scale score from 90. So the person is 90 based on this A of 0.88 plus 25.35, which is B, or 0.88, whatever. I use my class pad. I work out the answer will be 104.76, the scale score. So strictly speaking, this is not right because you can never get a test over 100%. Yeah? In that situation. So that's not, the scale score is over 100%. This is not appropriate.
Sir, have you ever had to do that? Scale it up because it's too hard?
No, haven't done that. But if you miss, actually, if people who miss the test, for example, not well or whatever, I have to use a standardized score. I will look at all the tests and do a standardized score. All right, last example, example 5. Very last one, example 5. So a new employee at a used car yard is offered the following weekly package. A fixed retainer of $220 and a commission of $350 for each car sold. Using past sales record, the employer constructed a probability distribution model where X is the number of used cars sold. Why did I spell it as E-S-O-L-D? Sorry.
What's a retainer?
By a week by an employee. So a retainer means it's just like a fixed pay that they give it to you. Yeah,
Right.
They give whatever, whether you sell a car or not, you get $220. That's a retainer. So what you got to think about is how do you work out the weekly pay? So the weekly pay is actually if I let the weekly pay be Y. So Y is 350 times X plus 220. All right. So if it sells 2 car, 350 times 2 car plus 220. But the thing is, what you want to do is find the weekly pay the employee could expect, or the expected pay, which in this case, because you know it's probability mass function, is the mean.
Yeah.
All right, you need to work out the expected value of X as well. So EY, the expected value of Y, equals to 300 times the expected value of X plus 220. See the transformation. You're going from X to Y now. How you relate X to Y? The weekly pay. Yeah? So, therefore, you should be able to work out expected value of X is 1.32. Use your calculator. 0 times 0.26 plus 1 times 0.35 plus 2.0.25 plus 3.0 times 1 plus 4 times 0.03 plus 5 times 0.01.
Can you do that quickly or do you have to do it manually?
Sorry?
No,
You have to do it manually or do you can do it?
You can use a calculator, that's fine. This
Yeah,
is a
but-
calculator assume section. It really doesn't matter. In this case, it doesn't matter.
Yeah, you just use the calculator.
You can use the statistics, you can also just use the multiplication.
Yeah, use that one.
And it works out the expected pay is $682.
I haven't packed on my iPad yet.
Alright?
Alright.
So I'm going to stop here.
Yeah.
Sadler doesn't have a lot of exercises, so I picked up something else for you to do.
No.